Alright, this is the second part of rational function arithmetic. Now, in the previous part, we talked about when you have two rational function, how do you combine them with addition or subtraction? Alright, at the end, we want to make it into one single term like this. Now, in this part, we don't want to look at the opposite operation. We call it a partial fraction expansion. If you have one expression like what you have on the left hand side, alright, and you want to expand it following the blue arrow, expand it into two terms. Now, the denominators come from the original ones, alright. The denominator will be like this and like this, like the original one, x minus 1 and 2x plus 2. So what remains to be done is to find out these two question marks. What are they? Alright, what are they, so that the left hand side equals to the right hand side. So maybe I give it names, right? We call this A and B. This is A and this is B. Now we use the idea of identities to do that. Alright, first of all, look at the right hand side. We have A over 2x and 1 and B over x minus 1. Alright, we want to find out what A's and B's, what they are. Now, in order to take the common denominator, that would be the LCM between them, 2x and 1, x minus 1, alright? And over the top, on the numerator, we have a times x minus 1 and b times 2x plus 1, alright? And that amounts to, we collect all the terms with x, alright? And all the terms without x. We collect the constant term and the x term. If there were x squared term, we collect the x squared term as well. Alright, and that divided by 2x and 1x minus 1. Alright, we know this one is identical to 3 over the same numerator, the same denominator. Alright, we know that it is the same, but the 3 can be expressed into 0x plus 3. Alright, so we can invoke the principle of identities, that we know. Applying the principle of matching coefficient, we have a and 2b must be the same as 0, alright, and that b minus a must be the same as the 3 here. Alright, so we can set up two equations, a and 2b equals to 0, alright, and then we have b minus a equals to 3, alright. Upon solving these two equations, we got the values for a and b. Upon solving these two equations, we have a equals to 2. Oops, I'm sorry, a equals to minus 2, am I right? A equals to minus 2 and b equals to 1. We have a equals to minus 2, b equals to 1. So that we have the partial fraction expansion. 3 divided by 2x plus 1, x minus 1 can be expanded into minus 2 over 2x plus 1 plus 1 over x minus 1. This is it. Alright, this is the result of the partial fraction expansion. Oops. Alright. Okay, so maybe let me quote another example based on this one. Alright. Now another example is like that. It's okay, partial fraction expansion. Another example is like that. We have 2x squared minus 1 divided by x squared minus x minus 2. Alright. If that equals to a plus b over x minus 2 and c over x plus 1. We want to find out what a, b, c is, what they are. Alright. So the solution is like that. First of all, we take the right hand side, right? And we want to change it into a common denominator. X minus 2, x plus 1. Alright. And on top, we have a, x minus 2, x plus 1, plus b times x plus 1. Alright. Plus c times x minus 2. Alright, and that will give me, now we collect all the x squared term together. All the x squared term. Or maybe in this time we can try another method. Maybe in this time we try another method. We try the method of substitution. We have 2x minus 1, therefore identical to a times x minus 2x plus 1. I don't have to do the expansion. I think the expansion is too difficult in this case. So I would rather try another method in polynomial, in identity. I would try the method of substitution. I would put x equals to 2, for example. Put x equals to 2, for example. The right hand side will give me 7. The right hand side will give me 7. Now when x equals to 2, all these x minus 2 term becomes 0, so only b remains, that is 3b. Alright, putting x equals to 2, we have 3b equals to 7. And likewise, putting x equals minus 1, when x is minus 1, all these x plus 1 term disappeared. So we have 1 on the right hand side equals to minus 3c. Alright, so from here we have b equals to 7 over 3 and c equals to minus 1 over 3. And finally, for the a term, I think we cannot find a term easily with substitution. Alright, so maybe we can use a matching coefficient. If you match the x squared term, right, now there is only one x squared term, and this is the only way that will give you an x squared term. Matching the x squared term, I think it's easier to see that a equals to 2. Alright, this is when we match the x squared term. We have a equals to 2. And therefore, we know that the answer to this one is 2 plus 7 over 3 divided by x minus 2 minus 1/3 divided by x plus 1. Alright. So this is another example for partial fraction expansion. Alright. Now you may want to revisit. We may want to watch this part again because I think it's quite complicated and I skipped some of the important steps. Alright. The important part is the blue part, the orange part, and the green part. Right? How do you choose the substitution? How do you choose the substitution to put x equals to 2 and x is equal to minus 1? And the last part, for the green part, we decide to match the x squared term to get a. Alright. So these are the various approaches that we deal with polynomials, deal with identities, I'm sorry. Alright, so far we have been talking about addition and subtraction between rational functions. The last part will take 2 minutes to talk about multiplication and division. Multiplication and division is easier. I only want to give you one note on cancellation. When you want to cancel things, be very careful about this cancellation. Right? Say when you have 3 levels of fraction, a divided by b divided by c. Alright. If you have a fraction upon another fraction, so what does that mean? Now that means it's a over b first, and you divide by c, or it is a divided by b over c. Now are they the same? Let's see, are they the same? If you write something like this, alright, what does it mean? A over b over c. Is it a over b divided by c, or a divided by b over c? We discovered that they are not the same. For the first one, that would be a over b divided by c, and that is a over b times 1 over c. So that is a over bc, right? While the next one, you have a divided by b over c, and that means a times c over b, and that will give you ac over b. Now it's plain to see they are not the same. Alright, they are not the same anymore. One is a over bc, one is ac over b. So now lesson number 1. When you want to build one fraction upon another, be very careful. Don't write a over b over c because they are not the same. Doing a over b first or doing b over c first will give you different results. Alright. So this is one point about cancellation. Another point is like that when you have some of the squares, people will always making mistakes like this, right? Divide by a, and then we have another example like p over q square divide by q. Alright, so can you cancel the a? Can you cancel the q? Think about that. Think about that. Can you cancel the a? Can you cancel the q? it turns out that you can cancel the a in this case on the left hand side. You can cancel, all right. But for p, you cannot cancel. I mean for q, you cannot cancel, all right. Because for q, it should be p over q square divided by q, and that divided by q will give you p over q square times 1 over q, all right. So not only it cannot cancel, but the power of q becomes even greater in this case, all right. While on the other side, we have a squared divided by c, and that divided by a will give you a squared over c times 1 over a, and that is a over c. So you can cancel the a. All right. Anyways, be very careful when you have to deal with these fractions, one fraction upon another. All right. And the last remark and the last note will be for square roots. For square roots, say if you are dealing with a over b divided by a over b times c over a, and c over a is entirely in the square root. All right, the square root a, you can do something with the square root with the a. You can do something with the a. All right, it can be simplified into 1 over b times the square root of ac. All right, AC. Now it is because when you have the general idea is when you have k times square root x, the k goes inside the square root and it becomes k square. Right, that is the general idea in dealing with constants or factors inside and outside of the square root. All right. Commonly we have like 1 over square root a. When you want to move the 1 over 2 inside the square root, it becomes a over 4 entirely in square root. Alright. So on this page, I want to remind you on the fraction cancellation and dealing with square roots. Okay. So that would be end of this chapter. Thank you.